So during this session, the next half an hour or so, the selective inventory management, as you are aware, the selective inventory management deals with not only one type of the classification scheme, say ABC, it deals with several other classification schemes. So during this session, I will be discussing to some in some detail two typical classification scheme. The first one is like say BED classification, and the second one is FSN, right? So so let us first talk about the BED classifications. Now, in the majority of the organizations, as I have already pointed out, ABC classification along with one or two additional classification schemes are used. Though we have mentioned that there are altogether 6 classification schemes, and in when you deal with a multi-division, multi-product manufacturing firms, so they're dealing with hundreds and thousands of items and facing the different sorts of the situations, like say there could be say purchasing from say within the country, there could be international purchasing from outside, and you deal with all sorts of items, like say you deal with raw materials inventory, you deal with say the finished parts inventories, you deal with say the finished goods inventories, you deal with purchase parts, and you also deal with the MRO items. So when you deal with all sorts of the inventory items, it's natural, and all sorts of the purchasing procedures you have been following for a long time. So obviously in those cases, for those industries or for those the organizations, you have no other alternative but to say use all these 6 classification schemes. But then sometimes the time could be a constraint. Sometimes all these the 6 classification schemes you don't need to use necessarily. You do not use necessarily. So hence you can be selective also. So out of these 6, usually 3 are always used. So that's why ABC is common, and along with ABC, BED and FSN classification schemes are also found to be essential in many instances. Now let us talk about the VED classification, how to collect data for VEC classification. That is the main issue. So the VED classification is based on criticality of an item. That means you have to define what is the criticality, and what is expected that given a particular inventory item, this item being used in a particular product or a process or in a machinery, and the criticality of this item is defined with respect to its functional value. Means how important that the functional value of that product with respect to the performance of the machinery or the product or the process. So that is the key in defining the criticality of an item. So what you need to do, that means you must be a technical person, you must know the design as well as the functioning of that particular system or the product or say the process, and then only you will be able to define the level of criticality of an item. Is it okay? So usually it is the responsibility of the designers, and their opinion will be sought. Inventory items related to operations and maintenance of machineries and processes. Okay, so in a manufacturing or in a service systems. are classified under Ridi scheme. So this point is to be noted. For classification of the items under this scheme, we need to define the level of criticality of each item with respect to its importance to the functional or use value of the machinery or the process of which it is a part. That means here is a machine or here is a process in which this part, this inventory item is required to be used, and this particular item with respect to this particular machinery or the process serves this purpose. That means what is its functional value with respect to the operation as well as the performance of the equipment or so the process under consideration. Okay, so this knowledge is a must. So the items which are vital for the functional value or the use value of the machinery or the process are considered as vital items. You may be knowing that any product, you should be aware of that there are 4 types of the values a product or the item may have. The first one is obviously the functional value or the use value, right? So suppose so the functional value. The second one is the appearance or say aesthetic value, appearance or esteem value, aesthetic value. The third one is actually the cost value, and the fourth one is the exchange value. So here for the Ridi classifications we refer to the functional value. Okay, so the items which represents the functional value of the product where it is used. So this is considered to be very vital. That means if suppose this item is not available at a particular instant of time, what you will find that you will not be getting the functional value from the product. That means the product stops functioning. Is it okay? Or the system stops functioning. Entire system the stops functioning. Similarly, on the other extreme, there are the parts which are in normal condition that is required, but they are not directly affecting the functional value. Is it okay? So they are considered as desirable. They are considered to be desirable. The items that are considered to have appearance or say esteem value, or say sometimes is a aesthetic value, are considered to be desirable. There may be one or more than one substitutes for these items. That means at one extreme you have the vital item, at the other extreme you have so the desirable one, means that is definitely preferred, but suppose it is not available, what you can do, you can get a substitute for this one. That means for the time being you can run the system. Is it okay? That means there is no, as such there is no effect on the functional value of the product. So the criticality is to be defined very clearly and explicitly. Essential items are those for which a few substitutes may be available with additional cost of procurement. Is it okay? So this way we define. That means there are 3 types of items. First one is the vital. That means if without which, or suppose this is not made available at any point in time, the entire system will be affected. Okay. If suppose the item is considered to be essential, it means that if it is not available, then at any point in time or at instance of time, then that means a substantial portion of the production systems will be affected, stops functioning, not the entire one. Whereas if it is a desirable one, that means as such the overall function of the performance is not affected, but maybe it is not performing well, or in future there could be some problems. So immediately you can have a substitutes, but the later one you just the substitute should be changed with the original one. So these are the 3 types of classifications. Non-functioning of vital items may render the machinery or the process useless. That means you will not be getting any performance or the function out of it. Non-functioning of essential items may jeopardize the functioning of a portion of the machinery or the process. This point already I have elaborated. And for a given list of n number of items, okay, the following data need to be collected for VD analysis. Now, as I have already pointed out that essentially this the classification is made, the procedure you followed, that is, while you follow the procedures, you must have enough knowledge to define the term called criticality. So, select a measurement scale for criticality. So, this is very vital. So, you may select a 4 or 5 point scale. Like suppose you use a 5 point scale. So, if you say the scale value is 1, it means the item is least critical. If you give a value of 2, the rating is 2, that means it is slightly critical. Similarly, if it is 3, 3 means critical, 4 means highly critical, and 5 means very highly critical. You may use a 5 point scale, and or you may also use a 4 point scale, but unnecessarily don't go for a 10 point scale. This will unnecessarily you make the system more complex, so that is also not desirable. While you select the criticality scale, you need to define the criticality level against each rating value. That means you need to very clearly define, is it okay, in narrative, what is least critical, right? So certain sentences you have to write, you have to define in the given context. Similarly, for all other say the terms which you use, like what do you mean by slightly critical? In many cases, while you try to define these items, so you may cite certain examples, because one of the key aspects you must keep in mind, that is this you develop. Definitely you are an expert, you have the knowledge, you have the understanding, so you will be proposing this VD classification, but then again the entire systems will be used as well as will be adopted by the people down the line. So their understanding also should be very correct. So that's why you need to write down the definitions in such a way that this is clearly understood by the people down the line for easy adoption of the classification scheme. Against each item I, like in the previous cases we have mentioned, that each item is referred to I, is referred to the functional diagram of the machinery. Now this is very important, or the process where it is a part of. Is it okay? So that means you refer to the functional diagram. Once you study the functional diagram of the machinery or the process, you will come to know that actually normally there could be different the modules in the functional diagram, but you find that this diagram is presented in a hierarchical form. That means what are the core components, what are the sub core components, what are the peripheral components, and how the machine starts, and how it starts functioning. All the units are running one after another. What is the main component? What are the linked components? So all these details you must know, and then only you can clearly understand that the item belongs to a particular module. This module essentially the core module or the main functional module. So obviously if this particular item, suppose it gets damaged and immediately it's to be replaced, and while you go for replacement you find there is no stock out of it, so obviously you have to wait. So the entire system is down, entire system is not working. So obviously that item is considered to be very critical, and that's why it is considered to be very vital. So this is the main say the approach or this is the way you use or you need to define the level of criticality. Against you need to refer to the functional diagram. Assess functional value of item I in terms of the level of criticality, the point which I have elaborated right now. Now next what you do, you prepare a table as follows. Now please study this this table. Like first one is, in the first column you will find there is an item number 1 to n. Next is the criticality rating. Okay, so you have to follow certain scale. So the criticality rating, suppose C1, C2, C3, Cn, like this. The ranking of criticality ratings. Now that means what you find that the C1, C2, C3, these are the categorizations like 4 to 5. That means there is a scale. Just suppose it's a 5-point scale. That means it is highly critical as well as very highly critical. That means while say you look at item number 1, item number 2, item number 3, say you find they're all rated as 4 or 5. So this is the first categorization. Next say few items, so the next set of items, not few, the set of items, you will find they're rated as either 2 or 3. That means it is slightly critical and critical. Is it okay? You refer to the 5-point the scale which we have discussed already, which I have mentioned, which I have stated. So they are considered to be the next category, and obviously the remaining items here, remaining items is up to n, what you find, they are all ranked as 1. That means it is least critical. That means it is non-critical also, you might say. So this is vital, this is essential, this is desirable. So this is the procedure you follow. That means the criticality you have to define with respect to the functioning of the product, and then you have to categorize them, you have to scale the values, so the rating scales. So now you count how many numbers, let's say like n1 numbers in B category, n2 number in E category, and n3 number in D category. So the proportion of items in n1 by n, n2 by n, and n3 by n. N is the total number. Actually this is n is the total number of items. Okay, so this way you present the table. Now from the above table we will come to know, for a set of items, the proportion of items in vital, essential, and desirable categories. Already I have mentioned. You look at the table, immediately you will get these proportions. In an organization, we need to identify and assess the current inventory control policies and systems related to each category of items, particularly V class items and E class items. Okay, so this for the time being, or if suppose there is as such there is no specific problem you come across for the desirable item, you may continue with the existing systems, existing inventory control systems for the class items. Now the next important classification scheme I am going to discuss, that is referred to as FSN classification, and again the core issue we will be discussing, that is how to collect data for carrying out FSN the classifications or FSN classification scheme. It is observed in the majority of the organizations that all the inventory items are not used at the same rate. Now this is the point to be noted, right? You have been using these inventory items for say for the last 5 years, for the last 10-20 years, for some of the items you have been using for the last 20 years, 25 years, 30 years, since the inception of the company, of the plant. So these items, obviously you are aware of its production rate. That means per month what is your consumption rate, how many units you require per day or per hour. So all these the data you have, Obviously, you know particularly in a case where you produce to capacity, you have created capacity for your plant, and what do you want? That suppose the case is it is produced to stock. That means the item has a constant market. Whatever say whenever you produce it, so there is a market for this one. Is it okay? So that could be the situation, produced to stock, not produced to say the order, produced to stock. So that could be the situation. So obviously for many items, almost all the items at this point in time currently, what is the the production rate, that is known. Whereas for certain items that are directly related to the produced products in an ongoing or recurring process, that means what you will find that the certain items which are regularly used for the production purposes, the remaining items, the consumption rate may not be that high. So what do you expect? That the items which are regularly used in the production purposes, usually their consumption rate is high, whereas for other items the consumption rate may be very low due to number of reasons. Is it okay? So it is a real problem of in any materials management executives he faces. He deals with this kind of problem, like some of the items are you have procured, they are occupying space, but they are hardly being used, and obviously you related this problem to the current inventory control policies, but there could be many reasons that why you have this excess stock, and where excess stock but there is hardly any production or say use rate. The reasons for low consumption rate are manifold. I'll just mention some of the important reasons. First reason is, you may note it down, first reason is the change in product design, change in production methods. That means if the design is changed, that particular item may not be required. Okay, you need the different type of item in the new design. Change in production methods, that is the second reason. Change in demand levels, it's obvious. Aggressive purchasing, that means someone has purchased these items assuming that these items will be will be consumed or will be used at a high rate, but actually it has not happened. Change in technology, this is an important factor. Forecasting errors in estimation of demand, this problem also you come across. And obsolescence of items, which in many cases may not be avoidable, it remains unavoidable. So these are the few important reasons for which the consumption rate may be very low. Items with very less consumption rate, a low consumption rate, may become a dead stock, and dead stock is a serious problem. So and when you deal with the dead stock problem, so the first exercise you carry out, that is what is the proportion of the items considered to be non-moving. This is the first exercise you have to do. So you have no other alternative but to go for FSN analysis. Is it okay? And later on when we deal with the excess stock model, okay, so you will come to know, say, in how many different ways the excess stock can be liquidated, can be disposed of. But first you need to determine the excess stock, and these excess stock in majority of the cases, these are considered to be non-moving. I am not saying that that even for the fast moving items there could be dead stock, there could be excess stock, but in majority of the cases we will find that the dead stock problem actually originates from say non-moving or non-moving items. So This dead stock occupies the physical space with huge amount of capital tied up, affecting both operational and financial performance. Is it okay? So you should take steps so that the tied up capital is released as quickly as possible for other productive purposes. It is important that existing inventory policies of slow and non-moving items are to be reviewed periodically so that excess stock is determined on a regular basis and liquidation or disposal of alternatives are adopted for increasing the working capital of an organization. Is it okay? So the working capital management is very, very important for any organization, and this is closely linked with the inventory management practices. So what are the steps to be followed for carrying out FSN analysis? Define and classify consumption rate under three categories: fast moving, slow moving and non-moving items. This is the standard practice in fact. For each category, the range of consumption rate is to be specified. Is it okay? The selection of consumption rate and its range in a given category mainly depends on the capacity and the production rate for each item in a given time period, with the consideration of allowances for wastage and scrap. So as such, there is no in any standard the rule or say some mathematical formulations. So in a given situation, you have to study the system closely, and then you decide, and you must refer to the past data of the consumption rate, and then you select the range. Okay. So and then you prepare a table as follows, like for the item I, the first column, in the second column consumption rate you specify, then the categorization of the items. That means first what you have to do, you have to set the rules for categorization, like the fast moving R1 and above, like 10,000 units and above, that is considered to be fast moving. Okay, per unit of time, could be a day, could be an hour, could be hour. Slow moving means like say 5,000 to 10,000, okay, units per hour, or say 3,000 to 10,000. Choice is yours. There must be some basis, right? And the non-moving below R2, you say okay, it's almost less than say 2,000 considered to be. So this definition, there cannot be any absolute the definition. So relatively you have to the select, okay, the range values. So once this is done, obviously looking at the consumption rate, you check whether it is in the first category or in the slow category or in the non-moving category or not. So the classification as per rules given, that is it is F, this is S, this is N. That means the number of items in F category, number of items in S category, slow moving, and number of items in say the non-moving case. Particularly you should be bothering about the non-moving items. Is it okay? Because if you do not take corrective measures immediately or the preventive measures immediately, it could be a serious burden on you, and it will affect the materials management systems significantly. So now you can definitely calculate the proportion of items, right? So when ABC, VD and FSN classifications are simultaneously used, in many cases you need to select out of 6 classifications at least 3. For all the inventory items, we have altogether 27 combinations. These combinations are represented in the figure below. So this way you calculate. That means on one y-axis you have A, B and C. In the y-axis, this is the x-axis, this is the y-axis VED, and then you have on the z-axis F, S, N. So the most important the category is most important items are the items which are A class items, vital items and fast moving items. This is on one extreme. And the other extreme is most unimportant item is C, Then you have the D, desirable, and non-moving. Now whenever you say it becomes a non-moving, now if this numbers is more proportionately is large number of non-moving items, that itself becomes a critical item. So here the fast moving may not be a critical item, slow moving may not be a critical item, but non-moving could be considered as very important or the critical item. Okay, so I conclude this session. So only the 3 classification schemes we have discussed in depth, and later on in the next sessions I will also be referring to say other classification schemes with so certain key points you need to remember. So I close these sessions. So the combinations involving A and B, V and E, and F and S may be categorized as very important. As I have already told you, existing inventory policies for these items are to be regularly assessed and improved. For items in remaining combinations, the existing inventory control policies may continue. So this is the concluding remarks. Thank you.